let's do the last write-up problem in the practice exam number 24. The Leaning Tower of Pisa is an architectural wonder. Engineers concerned about the tower's stability have done extensive studies of its increasing tilt. Measurements of the lean of the tower over time provide much useful information. The following table gives measurements for the years 1975 to 1987. The variable lean represents the difference between where a point on the lower tower would be if the tower were straight and where it actually is. The lean is measured in meters. Letter A is wanting to find the correlation R of these data. Use your calculator. State only the answer. So what we need to do is put all the information in our calculator. And luckily, I've already done it for the sake of time. In list 1, I put all the years down. Yeah, 75, 76. Again, really imperative that you check what you input in the calculator so that if there's any mistakes at all, you want to avoid it so your answers are going to be correct. So to calculate, actually, let me go through all of this just so it's all right. And yep, we're set. So to calculate the least squared or the correlation R, you're gonna have to click Stat, go to the second column, and you're gonna select, instead of 4, we're gonna select 8 because the least squared regression form that we've been accustomed to throughout the lectures is A plus BX. So press Enter on 8, and then press Enter again, yeah. And then look at that, it spits out our slope, which is a B, and our y-intercept A. Notice that the e to the -4, what that means is it's times 10 to the -4. So it's a really, really small number. It should be 0.000931 as a slope. If you've noticed, R isn't shown here. If R isn't shown in your calculator, you need to turn diagnostic on, and you can turn diagnostic on by going to catalog, going second 0, and then all the way down, go to letter D, diagnostic, and it's right here. Press enter and enter again, and it'll say done, and then go ahead and do calculate number 8 one more time, and you should get R, 0.9939. So the question tells you just need to put the answer. We already know that you're using the calculator. If you want to be safe, you put the whole thing down, but as a rule of thumb, you can just go 2 decimal places, so 0.99 is pretty okay, or 0.994. The most minimum amount of decimal places is 2. If you go lesser than that, I'd probably mark you down for points. And then the least squared regression line, again, y equals a plus bx, so the equation is going to be y is equal to a 1.12 plus b 9.31 times 10 to the -4 x. Specify that part, times 10 to the -4, otherwise you're going to be wrong. And that's it for A and B. I'll do the... Actually, let's do letter C right now, too. Is the relationship strong? Look at it's 0.99. Yes, it is strong. It's close to 1. And letter D, I'm going to skip that because I'm going to assume that you know how to make a scatter plot, and that's going to take a lot of time for me to draw it out. But look at that. Look how many points it is. It's 10 points to draw a scatter plot. So don't screw up on your scaling. And when you're drawing the line to best fit all the data, just do the best you can. What you want to do is to be completely accurate is plug in a number in years for x into the equation that's not in your data set. So 1974, plug that in for x, and it will spit you a y. And then plug in 1988. And so those 2 points, x and y points, you're going to connect those 2 points, and it also will it also needs to intersect the x bar, y bar. But you know, we're not going to be too critical. At least I'm not going to be too critical about all those things. I just need you to draw it and draw a line that best fits the whole data. All right, that's it for A, B, C, D.